Here is a graph that I want to start with. So recently I have been watching Big Bang Theory a whole lot. So thought why not pick a graph from here. It will also give you a picture of what do we mean by a graph here in this context. The graph we have picked here looks more like a Twitter kind of a network. Twitter kind of a network tells you who follows whom, or let's say who likes whom. So what this graph is showing you, those of you who watch Big Bang Theory might be aware of the names of these characters. Even not otherwise, that is fine. Maybe I can just mention it out for you. I'll get a little text box from here. So these are some friends from the series. He is Leonard, and if you already know these names, you can considering fast forwarding the video or skipping the next 30 or 40 seconds. So I'm just writing the names of these characters here. Sheldon is like one of the main characters of the show. So anyways, what this graph is representing here is who likes whom in this popular television sitcom. So the connections here tells that Leonard likes Sheldon, Sheldon likes Amy, and then Penny likes Amy, so on and so forth. Now I want to represent the same in the form of a code. I want to store the same information in my computer so that later on I can analyze this graph. So let's get started with it and see how we can do it. So I'll get my Jupyter notebook over here. So I have a graph here which has 4 nodes. So every person here represents a node. So I should have a graph with 4 nodes, and these arrows here, they are called edges. So my graph should have 1, 2, 3, 4, 5, 6 edges. So 4 nodes and 6 edges. So let's see how we can get started here. So I need to import the iGraph library which we installed in the last video, and I'm going to give it an ls as IG, and then we are going to use this class called graph from the iGraph library again and again. So I'm going to get that. So from iGraph I want to import graph. So these are the 2 lines that we need, and then we are good to go. You can run this cell or do a shift plus enter, anything is fine. So I run this, it is now imported, and now I want to create a graph. The command is simple. I'll say g equals to graph. It will create an empty graph for me. Basically, I will have an object of type graph. So it will create a graph, but as of now, there is nothing in that graph. So let me run this cell. The graph has been created. If you want to see the properties of this graph, you can ask for its summary. So you say summary G, it says summary is not defined because this function you will find it in the iGraph library. So I'm going to write ig.summary G, and then you'll see a few things here. What they tell is U means the graph is undirected. Now, well, but you see we wanted a directed graph. If you see here, these edges, they have directions. Right? If you look at the friendship between Penny and Amy here, Penny likes Amy, but the graph doesn't suggest that Amy likes Penny back. Now this is just an example. I'm not commenting on what's actually happening in this sitcom. But then the point is that this edge here, it is directed. However, the graph that we have created is undirected. So I'll show you what it means and how we'll correct it later. So the graph is undirected. The 0 here means as of now we haven't added any node or any vertex to this graph. So the vertex count is 0, and similarly the edge count, that is also 0. So all in all, it's an empty graph with no nodes and no edges. Now let us try to add some nodes here. So these are the nodes I want: Amy, Penny, Sheldon and Leonard. Adding these is very simple. So this object graph has this function add vertices. I'm going to say g.add vertices, and here I need to provide a list of my vertices. Since the list of my vertices are going to be the names of these characters, I'll write the names here one by one in a list, right, as strings. So I have Amy, Sheldon, and then Leonard and Penny. That's all. So 4 vertices will get added to my graph. I run this cell, and now you can look at the graph summary again. You can run it here, the same cell again, or just for the sake of clarity, I'll quickly create a new cell and run this again. So you see my graph now, it has 4 nodes, right, and 0 edges. And now you would notice that I have this one more label after U. So we'll slowly talk about it, what it is, what about it, right? So it is telling that in your graph, every vertex, it has been given some name. So these are the names that we have given. Don't worry much about it. It will become clear as we go further and further. All that matters to me is that my graph now has 4 vertices, but it still doesn't have any edges. Let us try to take a look at this graph. So I'm going to plot this graph because that is what makes the subject very interesting. So I'm going to say, you show me how this graph looks like. ig.plotg, and then you see some 4 circles in like the different corners of my window. That was not what I was expecting. So what I can do is, you see, in general, whenever you use this ig.plot function, it will use this much of space. If you want to reduce this space, and I want to reduce the size of this entire figure, I can draw a bounding box around it by passing a command here, bbox, bounding box, and I'll say you should fit everything into 300, 300. So this 300, 300 are the height and the width of the figure that I want to see. Units depend from monitor to monitor, but you see what it has done now? It brought this closer. Basically the figure size decreased. You want to decrease it further, you can go up to 250. So you can just experiment with different values and then see what turns out best for you. So I'm getting 4 nodes here. Okay, well, that's good. My graph has 4 nodes, but do you again see a problem? I don't know who is Amy here, who is Sheldon here. I don't see any vertex labels here. So what I can do is, I can provide it the labels. I'm going to use a slightly hardcore approach now, which I'll lift later. I'll say my vertices have these labels, and these labels are exactly this, the order in which I had added the vertices. So I'll say label my vertex by this list. So what it will do, it will label the first vertex as Amy, second vertex as Sheldon, so on and so forth. And you run this code, and then you see all the names here. Right, you can do some more experimentations here. If you want, you can increase the size of these vertices. So I can say that I can add one more parameter here in this command, and then you can say vertex underscore size equals to 25, and you see the size of these vertices have been increased. So you can use a lot of parameters here. We will explore them slowly. So as of now, I have introduced the labels and the size of these vertices. You can also change the color of these vertices. You can also bring those labels below these circles, so on and so forth. So there are many things that you can do with the help of Google search. What I am telling you here are some of the very basics. Now we have got our graph, and then I have some nodes, but I don't see any connections between them. And graphs are all about connections. Now I'll be adding some connections here. So similar to how I added vertices here, I can add edges. So I'm going to say g.add edges here to this graph. And what you are going to provide here is a list of edges. Just like you had a list of vertices, I have a list of edges. Every edge you are going to represent it as a tuple. So don't get confused here. You'll see many braces here. So this is your first brace. So these circular braces that you see here, they are the braces for the function add edges. The second brace you see here, they are because I'm going to pass a list over here, list of edges, and every edge will be a tuple. So between which two people do I want an edge? So let's take a look here. I want an edge from, let's say, Penny to Amy, and then one from Penny to Leonard. So let's add that here. You can say my first edge should run from Penny to Amy. That's my first tuple. That's my first edge, comma. Similarly, you can put your second edge here, and so on and so forth. You can put as many edges as you want. So let's look for some more. Let's say Amy to Leonard. Let's do only this much and see how does our graph change. So I have added the edges here, and let me do a shift and enter. It got added, and then I can again visualize the graph. So I'm going to run it here. You can also copy paste this command and put it here and then run it again. But then what makes Jupyter interesting is you can go back to the one of the old cell here and then run it again. And you see the moment I run it, my graph changes. Right now I have edges from Amy, Penny to Leonard and then Sheldon. If you want, we can also add an edge from Leonard to Sheldon and then run the cell again. Now you see I already have these edges. I don't want to repeat, so I want to add one more. I don't want to repeat this entire thing here. So I'm simply going to add one more, and since I'm adding one more, I can just use g.add edge and then I can provide that edge here. Let me see whether it works or not. Sometimes I'm also just trying to figure out stuff. So I'm saying that can I directly add the edge from Leonard to Sheldon this way, and I think it got added. Let me run this and then see whether it got added. Yeah, well, good. So it got added here, right? But again, one of the problems in our graph here is the edges, they do not have directions. Right? So what do we do about that? So we just need to do a small change here. So by default, when you create a graph here in iGraph, this command here g equals to graph, it creates an undirected graph. You can pass a parameter here saying that directed equals to true. Now the graph that it will create for you is a directed graph, right? And then I'll have to run the same code again because this one created an undirected graph for me. So let me now once again create this graph. Look at the summary of this graph. You see what happened? The U changed to D. So U was because it was undirected. Now this graph has become directed, and then I add 4 vertices, and then it shows me directed named graph having 4 vertices. After that, I'm not going to directly plot it. You see, because if I plot it here, I haven't yet added any edges. So if I run this, you'll see the same old thing, no edges added. I should come here and add all these edges. So this time I'm going to move this one up and add all these edges, not this one. So removing this, I run this code, my edges are added, and now I'll come here and then plot my graph again. So now this time you see directed edges, right? So that is how you create a very simple graph here in iGraph. You can change a few things here about edges. If you want, you can change the so what I generally like is making these edges a little bit curvy. You see, as of now, they are all like very straight edges. So you can give to what degree you want these edges to be curved. So you can set any number from 0 to 1. You see what happens? The edges become a slightly curved and the graph looks a little bit more fancier. And if you make it 0.9, they become all the more curved. 0 means not curved at all. So you can play around with all these kind of features. You have something called edge underscore width, or rather I think edge underscore color might sound interesting to you. So I want all my edges to be of blue color, and you do this code, all the edges become blue colored. And you can also pass a list here, so which edge you want in which color. We'll slowly look at that. If you want, you can also change the width of this edge. So let me say 4. You see the width slightly increased. So you can always play around with these parameters to make your graphs as visually appealing as you want. So yes, well, that is about how you create a very simple graph in Python iGraph.